So on this one, Ben, since it says solve the separable differential equation, you don't have to test if it's exact or not. It doesn't matter.
Oh, yeah.
This is just separation of variables. So you know how to separate variables, yeah? You just move them to opposite sides. So d theta. And now you just separate the theta, d theta with the theta, dr with the r, with the dr.
Right.
And this is a separable differential equation because they're multiplied.
Oh, yeah.
Right? So I could divide this tan theta here, and I can divide this r here.
Right.
So this becomes dr over r equal minus 2 d theta over tan theta. That's it. And now all you have to do is integrate both sides, and I left the integral to the right of the negative 2 because negative 2 is a constant, so I can just pull it out. Now keep in mind on these problems your dr and d theta have to be in the numerator.
Yeah.
They can be in the denominator.
Right. Yeah.
Okay. And now we just integrate both sides. What's the integral of dr over r?
That would be ln r.
ln r. Now, do you know how to integrate this?
That would be.
It'd be easier to rewrite this as, so tan is sine over cosine, so this becomes cosine theta over sine theta, d theta.
Yeah.
And now we can use substitution.
Oh, yeah, that's right. So it would be ln sine theta.
Use substitution. No. Ln sine theta. Yeah. Because if sine theta, I thought you said ln theta. So sine theta is u. So sine theta d theta will be your du.
Right.
You just differentiate both sides. So now we have ln r equals minus 2 the integral of du over u. So that means ln r is equal to minus 2 ln u plus c.
Yeah.
Okay?
Yeah. So it means r would be.
You know, I could.
Sine theta squared.
Yeah. So, well.
Negative or sine
R.
root.
Well, first, what you can do for you do that step, take this minus 2 and put it on. Well, first u is sine theta. And then you can take this minus 2 and put it on the power here, plus c. And then you can invoke the properties of the logs. So r would just be e raised to all this. Sine theta to the minus 2 plus c, or I could rewrite it as times e to the c.
Right.
And e to the c is just another constant.
Yeah.
So I can call this c.
It would be c e to
and,
the ln.
Well, since the ln and the e, ln is bc,
yeah,
so this just becomes 1 over sine squared, or sine theta to the negative 2.
Yeah.
And if I bring this down, then we get r of theta equals c over sine square theta, or what you can name it as c cosecant square theta, whatever you want. Yeah. Those are equally identical solutions.
Equally identical.
Right?
Yeah.
Questions?
Where's the on that one? Where's the other ones?
B. Okay? You want to write it down so you can start, probably
Yeah.
be easier to look at it there than